Hey everybody, and welcome back to another grind session. I just did this first one of the stack valid parentheses, and it was very difficult. It was a new concept of stack, but I want to jump over to 2 pointers and look at valid palindrome because it's another easy. I can bust this out quick and then I can go to sleep. So let's take a look. So I'm familiar with palindromes, and I'm just curious how we can solve this question. 1 second. So we have a palindrome if converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters that reads the same forwards and backwards. Alphanumeric characters include letters and numbers. So we want to... This is giving us a few hints, I guess. We want to convert... We want to first convert all uppercase letters into lowercase letters, and we want to remove all alphanumeric characters. And then we want to check the same forward and backward. So alphanumeric characters include letters and numbers. So we can write that. Convert all uppercase to lowercase. Remove all non-alphanumeric characters. Read the same forward. So we have an output that we're looking for. True if it is a palindrome, false otherwise. So we have a man, a plan, a canal, Panama. Remove all non-alphanumerics. Convert, including spaces. And then convert all uppercase to lowercase. And then we can check if it's a palindrome or not. So we have race a car. Race a car is not a palindrome, but race car would have been a palindrome. And we have an empty string is the same forward and backwards, so it would be a palindrome. So the first thing we're going to want to do, I think, well, when it says if this is under the preface of 2 pointers, that tells me that I need 2 functions. Or I guess 2 things to happen within this function. Well, we first need to check if it's an alphanumeric character or not. And that can look kind of ugly, so we're going to create a function for that. Is character. Is alphanumeric. And we can have self and C, self to inherit the object, C as the character analysis, and what we're going to do is we're going to return the ord. I don't know what ord is. Ord A. What does this mean? Order. Excuse me. The ORD function returns the Unicode point of the given character. Okay, that makes sense. This looks similar to the arrays and hashing question, where it asked the there was an arrays and hashing question where it used ORD. I kind of want to look for that just to get that extra context. I just clicked that. ORD, here. I was right. So it just converts the character to the alphanumeric like number. And I guess that's why it's called alphanumeric. So we have ORD used here. Let me review this for one quick second. So this one is group anagrams, where what we're doing is we have an answer, an empty dictionary, then we're looking at S strings, looking for the similar anagrams. So we're just counting the number of occurrences of each letter in each string. But when we look at ORD here, we want ORD of capital A and ORD C being less than or equal to ORD Z. Because when we look at the alphanumeric list, like the conversion list, Z is 44 and A, I guess capital A, is 10. Or Z is 35, A is 10. So we know that A is less than, because, or if we know C has to fit within A and Z, because it's all converted to integers. And we can do the same with lowercase a. And lowercase z. And we can also do the same with 0. And we can also do the same with 9. Very nice. So then what we do is we use this function is alphanumeric in this is palindrome function. So what we're going to do is we're going to create two variables, L, which we set to 0, and R, which is equal to S minus 1. So L corresponds to 0, and R corresponds to length of S minus 1. And what we're doing here is we're basically looping through the entire string, where while L is less than R, we're going to do another while loop to say, while L is less than R and not self dot is alphanumeric, we're going to look within S at the location L, and if this while loop conditional returns true, then we can add 1 to the existing value of L. But we can check the other side. While L is less than R and not self dot is alphanumeric, S location of R, we can return R minus itself 1. I'm not completely sure what these do, but I'm guessing it's just it's searching from beginning to end and from end to beginning, because we have L being 0 and R being the length of the string minus 1. So we're just going in reverse order and iterating, changing these counting variables to check if S of L dot lower, which is, I'm not sure what dot lower is. Oh, it converts it to lowercase. So it's a string, a way to convert the string. And it's not equal to S of R dot lower. Then we can return false. So actually, I was correct. What this does is it actually does go through and searches from back to front and front to back. Or it goes front to back and back to front respectively for L and R. And if they're not equal and they're both lowercase, then we can return false. And it's like we don't even have to get rid of the spaces or the commas, because we're just converting them to alphanumeric characters. So if they don't equal at any point in time, then we can return false. Otherwise, what we're going to do is we're going to add 1 to the existing value of L, and we're going to add 1 to the existing value of R. And if everything shakes out, then we can return true for the entire function. So when we watch the video solution,
hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve the problem valid palindrome. I'm actually going to be solving this 2 different ways, and I think both ways are definitely going to be helpful to know in an interview setting. Before we start, I just want to quickly mention that this problem is actually a part of the blind 75 list of questions, and luckily we have actually solved the vast majority of the blind 75 questions. I even have a playlist of all of these questions in the description if you want to take a look. And of course, we will be finishing one more today, getting one step closer to 100% completion of blind 75. The list, and we are ignoring cases. By ignoring cases, they mean upper and lower case. So in the input string, you can see the leftmost character is capital A, the rightmost character is lowercase a. Both of these characters are considered the same. So if we had a string, an input string like big A, lower a, this string itself is a palindrome. So we do return true.
Oh, I guess. Oh, this is where I messed up.
We are ignoring the cases of the characters. And also, when they say we're only considering alphanumeric characters, basically it means we can ignore everything that's not an alphanumeric character.
That's what I messed up here.
Alphanumeric, basically everything from uppercase A to uppercase Z, everything from lowercase a to lowercase z, and everything from 0 all the way to 9.
So
right? Every character and every digit.
Basically, if it ignores the alphanumeric characters, if it's saying if it's not alphanumeric character, then it just moves to the next one. And if it yeah, so if it is alphanumeric, then it just checks, or then it goes to the next one. It just adds one and subtracts one to the list, and keeps going, I believe. I'm missing something.
Like a palindrome initially, but the answer is yes, true. It is a palindrome because, and actually before we even get into that, what is a palindrome if you don't remember? Well, basically the easiest way to check if a string is a palindrome is basically if it reads the same way as it does when it is reversed, meaning if the string is the exact same even after it's been reversed. So for example, A, B, initially, let's start at the beginning, right? And then next character A, next character N. So we just took this from the beginning of the string, a man, right? So let's start at the end of the string. We have a lowercase a, right? And then we have a lowercase m. Then we have a lowercase a, then we have lowercase n. So even reverse. And it turns out that if we, take this string and remove all, we reverse it, it will be the exact same string. Characters from this, keep solution. Okay, so now let's code it in kind of the two ways. Most languages like Java have a built-in function to check if a character or a string is alphanumerical. Python at least does. So we're checking if this character is
so we don't even have to check if it's alphanumeric.
We want to include it in the new string. So we're going to go ahead and take that character and add it to the new string. But one thing you don't want to forget is we want to make sure that every character is lowercase. So before we add it to the new string, we want to make sure that it is lowercase. So we'll convert it to lowercase. And then we're done with that. We have the new string. We removed all the other characters from it. Now we just want to check if it is the exact same when it has been reversed. So we're just going to take this new string, compare
Okay, let me
it to
look at
the
this new
reversed
solution.
string,
If C is alphanumeric, then we can look at new string plus equals C dot lowercase. So we add the new string. We add this C dot lower to the new string.
Which in Python you can do like this by, this is the syntax for reversing a string. So if they are equal, then we can return true. If they're not equal, this will return false, which is what we want to do to determine if it's a palindrome. So now let's run the code and make sure that it these with the solution that maybe your interviewer won't want you to use. Maybe they won't want you to use this alphanumerical function and they want you to implement it yourself. And maybe
that's
they
what we
don't
did
want
here.
you to use extra memory. Clearly, we used extra memory by building the new string, and we actually used extra memory over here when we reversed the string.
That's also a new concept that I'm starting to pick up on is memory allocation. So whenever you instantate, what is it? Instant something. You're adding memory requirement.
That was the reversal of the original. So we revert extra memory by building the new string, and we actually used extra memory over here when we reversed the string.
So also when you reverse the string,
that was the reversal of the original. So let's see how we can actually improve this solution. Okay, so now let's see how we can actually solve this problem with constant extra memory without using extra memory, without creating a new version of this string. And the main way is going to be by using pointers. So we're going to have two pointers, a left pointer and a right pointer. Because remember, there are multiple ways to check.
Oh, that was another mistake I made. So pointers. Pointer's not necessarily, two functions, but two pointers is like, it's pointing to two sides. It's checking two sides of the same string at the same time.
We don't have to reverse it. We can just compare the left character and the rightmost character. If they're equal, then we shift the pointers in. The left pointer comes here and the right pointer goes here. And then we can continue to check to make sure that the characters are equal. If they're not equal, then we return. But how do we know when to stop? Well, we're going to keep incrementing the left pointer and we're going to keep decrementing the right pointer until eventually they meet in the middle, or the left pointer, passes the right pointer, right? The left pointer becomes here and the right pointer is over here. That's how we know when we can stop. Or maybe they will meet exactly at the same character if
I'm looking
the
at
length
this
of the
to
string
see.
happens to be odd. Okay,
Well,
so that's
L is
actually
less than
pretty
R.
simple. Not too bad.
L is less than R.
What are we going to do? Okay, left is here, right is here.
Okay,
this is
so
capital
once
A, but of course we're going to convert it to lowercase.
Once the value flips here, L and R, then you know that the pointers have overlapped or gone past each other.
Okay, so they're equal, right? Okay, so then right pointer is going to be decremented by 1. So the right pointer is going to be over here at the M character. Left pointer is going to be incremented by 1, and it's going to be here. Well, we're at the space character. But remember, we want to ignore spaces.
Okay, this was my next question that I had. So we have the space character and the M character. The pointers are at the same spot. But I just wasn't sure how you're able to look at this and say, okay, increase this while not increasing this side. Like where you're only changing one pointer at a time.
I want to ignore everything except for alphanumerical characters. And can we try to do this without using a built-in function? Well, let me show you how we can kind of do that. Basically, I did some quick Googling, and we're actually going to use ASCII values to determine if a character is alphanumerical.
Okay, that's what we figured out. That's what we figured out.
Using this information in pretty much every language, want to compare this character with the character M on the right side, do we?
Because the confusion here for me is, okay, we're at the same character spot, like we've incremented our two pointers, but this is a space and this is a character.
Because we want to skip this character, so how do we skip it?
We want to skip it.
We can create a while loop. So while our left pointer is not alphanumerical, then we're going to increment left, right?
Okay. That makes sense. So it's like, that there is a possibility all the characters would be the same if there's no alphanumeric, if there's no non-alphanumeric characters. So it doesn't matter if they exist or not, or how many times you skip a loop, every character is going to be the same. Or I guess if you're going to compare it, and you'll just break out of the loop if it doesn't equal.
So we're going to keep incrementing left while it is not a alphanumerical character, because we want to ignore characters that are not alphanumeric. So we're going to increment left one more time. Now, luckily, it is a alphanumerical
That's really
character.
cool.
It's the character M.
That's
so
such a really neat solution.
Right, they're exactly the same. So we continue with our algorithm. We decrement R over here, increment left over here. Right now, they're both at the same character. And
man, these are the moments that I it's like the buildup is so long sometimes, like the 20 minutes into the problem. But when I get these little hits of realization, that's the fun part for me.
So that's the main idea. I won't run through this entire string because it's pretty long, but eventually the strings will meet in the middle. For example, over here somewhere maybe. At that point, we'll see, okay, they're at the same character, and then we'll say we can stop our algorithm. We've determined it is a palindrome, and then we can return true. So now let me show you how to code it up. The benefit of this solution.
Wait. I look at this, and I think a little bit more confusion comes to my brain. So we have our L and our R. If L keeps going... Oh, it doesn't matter. It doesn't matter. Because I'm thinking, oh, what if L never reaches R? And it just loops indefinitely to like 100. But R, because R is set to the length of the string, it doesn't matter if there are 100 underscores that take up space, they're not going to overlap until they have looped far enough to reach each other. Hopefully that makes sense. That was a little vague, but it's okay.
It's still a linear time algorithm. It's still
It's
big
new
O of
connections
n
in the
because we have to
brain.
iterate through the entire string, but the memory complexity is big O of 1 because we're not using any extra memory in this case. Okay, so now let's get into the code. First thing I'm going to do is write our alpha numerical function. So it's going to take in a single parameter, just going to take in a character, and then we're going to determine if that character is alphanumeric or not. How can we determine that? Well, I was using...
Okay, we went through this.
It's going to be similar.
I want to see this. I want to see his explanation for the code.
If it's not alphanumeric, this will return false. Okay, so we got our helper function out of the way. Now let's actually write the algorithm. As I showed in the drawing, we're going to have two pointers, left and right. Left is going to initially be at 0. Right is initially going to be all the way at the right side, so the length of the string minus 1. And remember, we want to continue the algorithm. We want to check if it's a palindrome while the left pointer is less than the right pointer. The pointers have not met each other yet or crossed each other. And so now we get to the point where we actually want to compare the characters. So we want to take the character
Okay, that makes sense.
left.
That's what we kind of came to the conclusion
right,
for.
And if they're not equal, we want to return immediately, right? Because if we find a single pair that's not equal, then we know it's not a palindrome, so we can return false immediately. But did we forget about anything? Well, the first thing we forgot about is we want to make sure to only compare the lowercase versions of each character. So let's convert this to lower and convert this to lower. So that's good. So if one of these is uppercase, one of them is lowercase, we're still good. But did we forget about anything else? Well, we never called our alphanumeric function, right? What if one of these is not an alphanumeric character? Well, we can't have that, right? We shouldn't allow that to happen. So before we even execute this if statement, let's make sure both characters at left and right are alphanumeric. So while it's not alphanumeric, so for example, while the character at position left is not alphanumeric, what do we want to do? Well, we want to increment that left pointer, right? So we can +1 to this. But one thing we want to make sure is that the pointer never goes out of bounds. So let's just add a checks to make sure left is less than right, for example. This will make sure that, of course, it never passes the other pointer, and it'll also make sure that the pointer doesn't go out of bounds. And we want to make sure to do the exact same thing for the other position. That's interesting.
I didn't really think of that as a
right.
I didn't consider that.
Greater than left, and the character at the position right is if it's not alphanumeric.
Oh, does that mean this is wrong?
We want to decrement the right pointer by 1 instead of incrementing. But both of these while loops will make sure that both characters are alphanumeric before we do the comparison, which is what we wanted to achieve. So then this will return false if it's not a palindrome. If the entire loop finishes, that must mean that the string is a palindrome. So then we can just go ahead and return true. Oh, and actually one more thing before I forget. After we do the comparison, we want to update our left and right pointers, right? We want to compare the next position.
Yeah, that makes sense.
Let's just run it to make sure that it works. Okay, I was dumb. In Python, if you want to call another function inside of an object, you have to use the self keyword. So the other solution, even though no extra memory needed, as you can see.
I like that. That was fun. I wonder if that's a mistake. Is this a mistake? What? I wonder if that's caught on his thing. But I'll check that off. I like it.
Hey everyone, welcome back, and let's write some more NeetCode today. So today let's solve the problem valid palindrome. I'm actually going to be solving this 2 different ways, and I think both ways are definitely going to be helpful to know in an interview setting. Before we start, I just want to quickly mention that this problem is actually a part of the blind 75 list of questions. And luckily, we have actually solved the vast majority of the blind 75.
I like the comments on here. Maybe I'll look through those a little bit more. And did this guy win? Okay, I like it. Thank you.